In this video, we're going to talk about measuring segments and angles. Now, there's a lot of vocab for this, so bear with me. But first, let's talk about the three undefined terms of geometry: points, line, and plane. So these don't have a formal definition. They're just kind of like, but they are the key building blocks of geometry. So let's go over each one. A point is represented by a small dot symbolized by an uppercase printed letter, has no dimension. So it's just like a point. We're saying this is that point there. It has no width, length, or depth. But we're saying unknown. This is where we're standing. Like this is our location right there, P. So how do you write it? You just write point P if you want to, or you just write P. So if I see just a big capital letter, I think that's a point. Or you just say point P. Next is a line. So lines are connection points that extends to either direction. So we have arrowheads because it says it goes on forever. If you want to symbolize a line can be symbolized by 2 points, AB or BA, doesn't matter what you do in order. Or if you have we could put like a little small strip L, like L here. That lets us know, oh, you see that? That's line L. So the notation would be something like L, or more commonly, use the two letters. So you could say AB, and usually put a little line above it. Or we could say BA. These are the exact same line because they go on forever. So it's just a series of points that go on forever. It's a line. And that's how you write it, right? Either two letters. So if I see two letters with the line on top, it's a line, right? Or you could do one curvy letter, one scripted letter. Okay, a plane. The plane is represented by a four-sided shape that looks like a floor or wall. The plane extends without any. So it's that kind of line, but it's like a 2D line. Where a line is like one dimension, just goes left and right. A plane is like a 2D line, goes left and right and up and down. Extends in two dimensions. The plane can be symbolized by 3 points, X, Y, Z, not in a straight line. Or it can be uppercase letter M. So when you do a plane, if you want to symbolize, we need 3 points, but they can't be in the same line. So if like there's a C right here, we couldn't use that. But we could use these three. So we could say plane X, Y, Z. So that's one way to name a plane. Or you can just use a capital letter. Plane M. Right, so you can use a capital curved letter, scripted letter. Okay, let's talk about a couple more vocab. Points that collinear means they're all on the same line. So points that are on the same line. So if we have this diagram here, I want to need 3 points that are collinear. So I need 3 points that are all in the same line. So like here's a line. So these 3 points will be collinear. V, R, and S. The next one, name the 3 points that are non-collinear. So similar idea, right? Non-collinear is exactly as it sounds. So not on the same line. So if these three are on the same line, I just gotta pick 2 of them and then one that's on the same line. So like I say V, R, and Q. Those are non-collinear. So V, R, and Q. All right, there's lots of answers there. You could go on VRT, you could go on SRT, lots of answers. Coplanar, similar idea, but points on the same plane. So name 3 points that are coplanar. So you might go, look at this plane here, right? So you'd say something like CBA, that would work. You could also say BEA, right? And honestly, any 3 points that are not on the same line are coplanar, right? As long as you don't pick DBF, those are on the same line. That's the one rule. They can't be on the same line, right? If you pick CBD, that's coplanar too, because you can make a plane out of 3 points. So all three points are coplanar if they're not on the same line. Name 4 points that are non-coplanar. So like that's the right idea, right? So 4 points are not coplanar. So if you do 3 on the same line, like D, B, F, and then one that's not, those would be non-coplanar. So I could say A, F, B, and D. So those are non-coplanar. Okay, segment. So kind of like a line, a segment's basically a line that has endpoints that actually ends. It doesn't extend forever. Right, so it's part of a line. And then the way you symbolize a segment, just like you do a line, you do 2 points, but notice in this case we don't put the endpoints. We don't put the arrows, I should say. So this will be our line segment AB, where this is an endpoint. And this is an endpoint. We'll just write AB, the line, or BA, the line. Right, so those are line segments. Array, it's kind of what it looks like. It looks like an arrow. Array's a little different. In this case, the points actually matter. So like when we did a line segment or a line, it didn't matter if you did A, B, or BA. Same thing. In this case, it does matter. So array has direction, right? So when array, we have initial point to the starting point. So this is my initial point. And then we have where all the points are going, which direction it's going to. So it could be here, it could be there. Like as long as you have to have the initial point's the key there. when you write the notation for array, you have to start with the initial point and then which direction it's going toward. So my notation would be CD, right? We're starting at C and we're going the direction of D. That's how you write array. So this would be called our direction point. Okay, opposite rays. That's two rays with the same endpoint that make a straight line. So if you take this concept going, like we start at C and we go in either direction. Over here, if you think about it this way, if we start at N and we go this direction, that is ray NP, right? Starting at N going to P. An opposite ray would start at N but go the opposite direction, go toward M. Right, so those are two rays going the opposite direction, right? One starts at N and goes toward the M direction, and one starts at N and goes toward the P direction. Those are opposite rays. And those rays together, they would form the line MN, or you could say the line MP, or the line PN. They're all the same, right? Lines go on forever. So all these are equal, right? MN and P, they're all the same. Since it's a line, it goes on forever, all the same. Rays matter, right? It matters where you start and where you end. Intersection. Intersection, the set of points that figures have in common. So it's just where figures cross or they intersect. If a line and a plane intersect, so you can see a picture here, right? So you have a line, you have a plane. Their intersection will be a point, so they're gonna cross right there. So like think of a piece of paper with like a pencil going through it. So this will be a point. I always think of planes like a piece of paper, and then like a line's kind of like a pencil. If two planes intersect, if you have like two papers that are trying to cross each other, they intersect at a line. It's a little harder to think about, but like if you see this line crosses here and then this line crosses there, they'll kind of like cross right there at that seam. So that's a line. They intersect that. Oh, let's talk about angles. So an angle is formed by two rays with the same endpoint. So it's like you get a ray here, and then you combine it with an array here, and then you get an angle. And we have special names for a couple things. So like the sides here, this is called a side. And the same thing with the other side. It's also called a side. So the rays are sides. And the point where they meet, we call that the vertex. So this guy right here is called the vertex. It's a very important concept. Okay, how do we like label like when we do a line, right? It's two letters. We can do array. It's the starting point, so BC and BA. How do you do an angle? Well, there's three ways to do it. One, if you're so lucky and there's only one vertex, you could just write the vertex, angle B. Even shorter, you don't have to write the angle. We have a symbol for it, like that. I know my symbol looks like an L, but it's supposed to be like a little angle B. That's one way to do it. Another way to do it is to pick 3 points, so like A, B, C here, but the vertex has to be in the middle. Very important. The vertex has to be in the middle. So you can't just say A, C, B, because if you say A, C, B, I'm thinking, okay, it goes from A to C to B, and that'd be my angle, which doesn't make sense in this case. So 3 letters, vertex in the middle. So you can say like A, B, C. Again, notice the vertex is in the middle. Or you could say C, B, A. Right? Again, that would also keep the vertex. You go C, B, and then A. So that would be my angle there. The measure of an angle. So another way to, so if you see this symbol, I should say, so the M before that, that means they want to know the measure of it. Like how big is that angle? Right? So we're going to represent that in degrees with the little degree sign. It's like how many degrees up, like think of protractor. We measure angles with a protractor to tell you how big an angle is. So in this case, the measure of angle ABC is 32 degrees. So that's like how wide it opens. If you want to do that in symbols, instead of writing measure, like instead of writing angle here, you can write the little symbol. Instead of writing measure, you can write the little M symbol. So if it says, oh, I want the measure of angle ABC, which is also 32 degrees. So now that we know what angles are, we could classify them different ways. There's 4 different ways to classify them. The first one is acute, right? It's very acute. It's small. So it's something less than between 0 and 90 degrees. So like if I made this 25 degrees, that would be an acute angle because it's less than 90. I mean, you could say the measure of angle B equals 25 degrees. Like that. A right angle, right means exactly 90 degrees. So it has to be like exactly 90 degrees. So that right angle there, like a corner of a wall. If you see this mark, that mark means it's a 90-degree angle. So that right angle mark, anytime you see that, we know it equals 90 degrees. Right, so this is the right angle. We can also write this as like the measure of angle DEC, right? 30 letters, DEC, or just E is also fine, is 90 degrees. And you might see perpendicular to each other. So I could say ED, right? The ray that way and the ray this way, EC, are perpendicular. That's an upside down T that lets us know that they are perpendicular. And perpendicular means that they form a right angle. So if you ever see that, that also basically means that they're 90 degrees. So all different ways to say 90-degree angle. An obtuse angle is an angle that's larger than 90, so it's obtuse. It's bigger than 90 degrees. So we can make this like an angle that's like 130. So I could say the measure of angle PNM is 130. That'd be an obtuse angle. Any angle that's bigger than 90 but less than 180. Now a straight angle is an angle that's exactly 180. So anytime you have like a straight line, like right, anytime you have opposite rays, one ray going that way, one ray going that way, that makes it 180 degrees. So that's a straight angle. So you can even say this angle. I could say angle RST, right? RST is the straight line. So anytime you have a straight line, 180. Okay. Adjacent angles. So adjacent means next to. If you're adjacent to something, you're next to it. So adjacent angles are angles that are next to each other. So they're going to share a common line. So like if I think about angle ABC, that's gonna be next to either CBD or you can even say CBF, right? Like these two are adjacent. They both share this middle line, right? So I could say something like angle ABC. Again, note if I do ABC, that's from here to B to C, like that, right? That whole portion. That's adjacent to, we'll say CB, and then from here I could go anywhere. I could do this whole thing here, right? CBF. Right? Those two are adjacent because they share this middle line. So they're next to each other. Those are two angles that are next to each other. I could also do a smaller one here. You could say these two angles here, right? This angle and this angle here are adjacent. So those are adjacent angles. Non-adjacent, two angles that don't share the same side. So something like ABC. And let's erase this. What if I do DBF? Right? This angle here and that angle, they do not share a side, right? There's this angle's in the middle of it. So that angle and that angle are non-adjacent. Okay, angle addition postulate basically says if you have two adjacent angles, if you add them up, you get the whole angle. That's what's happening here. So look at angle ABC. So angle ABC plus angle CBD. So CBD, so those two adjacent angles, you get the whole angle ABD. So that's angle addition postulate. If you have two adjacent angles, when you add them up, you get the whole angle. So for example, here it says ABD. So ABD, all of that is 87. And then we know they told us right here that ABC is 20. And they want me to figure out what angle. Well, that's an ugly. Let me erase this. There you go. Right, we know all of this is 87. So this whole thing here, let me do it like this maybe. And then we know this angle here is 20. I want me to figure out what this angle is. So, well, angle just postulate. 20 plus let's call this angle X will equal 87, right? This angle here plus this angle here is going to equal the whole angle. Let's do a little math. Minus 20 minus 20. X is equal to 67. Yay, algebra. Like that. Okay, the next one, right? So they want us to find STV. So STV. Well, I have this angle and I have this angle. So all I got to do is add up these two angles. right? Angle STVU plus angle UTV would equal angle STV. And this is 30, that's 80. So my angle is going to be 110. This is, by the way, it's a good example of where you do have to write all three letters. If I said angle T, what angle are we talking about, right? Am I talking about this whole thing? Am I talking about this one, this one? This is a case we have to use all three letters. So STU is 30 degrees. UTV is 80 degrees. And then the whole angle, STV. So this is a good example where you have to use three letters. You can't just use the one letter. Okay, congruent angles. Congruent angles have same measures. So anytime in general we say they're congruent, that means like they're the same. They're physically the same. They're the same measure. There's the same measurement. So that's what happens with congruent angles. They're the same. Okay, now that we know congruent angles are the same, like these are, when I say two things are congruent, I mean they're the same measurement, they're the same size. Now we can talk about an angle bisector. When you bisect something, you cut it in half. I'm not sure why I turned to that. Cut in half. So when you bisect something, you cut it in half. So if we're going to do an angle bisector, we're going to cut an angle in half. So that's what happens here. So CB bisects ACB. So ACB is all this, right? ACB. And they're telling us that CD bisects it. So this guy cuts it in half. What that means is that this angle here is equal to this angle here. And that's the marks we use. Those marks mean congruent. So they're called congruent marks. That lets us know that these two angles are the same because they have these marks. Like, oh, this mark matches this mark. These two must be the same thing. Sometimes you'll see congruent listed like this. An equal sign with the little tilde on top of it. That means congruent. So it means that they're the same size. So if I now that I know these are the same size, look what they tell us. ACD, that's this angle here, is x plus 10. And BCD, that's BCD is this angle here, is 3x minus 20. So the way I would solve this, right, is like, well, they're equal to each other. They have the marks. So this guy's equal to that guy. So x plus 10 equals 3x minus 20. Do some algebra. Minus x. Oh, you want to get rid of the smaller x, right? So these are gone. I get 10 is equal to 2x minus 20. Now let's get rid of that 20 to get the x. We want to isolate this x here, right? We had two x's to start off. Get rid of the smaller one. Now we want to isolate this x here, so get rid of that 20. We're going to add 20 to both sides. These cancel. I get 30 equals 2x divided by 2. We get x equals 15 degrees. Now when we're not done, the question wasn't just find x. It wanted us to find x. It also wanted us to find ACD. So how do I do that? Well, ACD is x plus 10. Well, we know what x is now. X is 15, so this one substitute it in. So 15 plus 10, we get 25. So angle ACD is 25 degrees. BCD would be the same thing, right? You could plug it in, but we know they're congruent, so BCD is 25 also. And then ACD, that's the whole angle there. Well, if this is 25 and that's 25, the whole angle must be 50. So that's how it works, right? If I know something's get bisected, that means you're cutting it in half. So that means that these two sides are equal to each other. In this case, that's how we solved it. And then once we got our answer, we don't forget answer the question. The question wasn't just find x, it was to find these angles. So if I know x is 15, plug it into one of these equations, or substitute it in, and you can find out what the value is. Move on from there. Okay, we can do the same with segment lengths. So here's a line segment. If I want you to ask how long a segment is, this is where absolute value comes in. When you talk about the length of a segment, we're just talking about how long it is. Length distance must always be positive, right? If I ask you like, where's the nearest like store, you're not going to say like, oh, it's negative 2 miles that way or negative 2 kilometers that way. You just say 2 kilometers, right? So length is always positive. So like here, what is KL? So we want to figure out how far is it from K to L. You could write either 15 minus 16, which you might say is negative 4, but we don't care about that. We just care about how far it is. We're going to do absolute value. So it's just 4. Or you could say 16 minus 12. which is 4. With that in mind, JK, right? JK is from here to here. Just go, how far is that from that? That is 5 away. Segment addition postulate. So much like angle addition postulate, same idea with segment addition postulate. If you have two segments that are next to each other, so AB and BC, if you add them up, you're going to get the whole segment. So this is for example real quick. AB is 3x plus 1. So 3x plus 1. BC is x minus 5. And then they tell us the whole angle, the whole segment is 40. Right? Well, the way to do this, if I add this segment plus this segment should equal 40. So 3x plus 1 plus x minus 5 equals 40. We're going to add these. And remember what we do is you want to simplify first. You want to add anything on the same side that you can. So 3x plus x is 4x. 1 plus negative 5 is negative 4. And then what we're going to do is we're going to add 4 to both sides. We get 4x equal to 44. Divide by 4. X is equal to 11. Now remember, that's not the full answer. They want us to go back and find AB. So go back. So go plug in, substitute 11 into there. You're going to get 33 plus 1, so 34. And then substitute 11 into here. And you're going to get 11 minus 5, which is 6. And we have our answers. Congruent segment, just like before. Congruent means that they're the same length or same measure. So there's actually 3 ways to indicate congruency. One, we could just say, like if I'm saying AB is equal to BC, we could say AB is equal to BC. Or we could say AB is congruent to BC. Or we could say, we have these little marks here. Just like how we did with the angles, if you see those tick marks, that means they're congruent. So the 3 ways to tell if 2 things are congruent, right? They could tell you they're congruent or they're equal, or we could have the little tick marks to let us know that. Okay, so here's our last example. Given AB is equal to BC, so these two good things are equal to each other. If AB is 3x minus 2, so from here to here is 3x minus 2, and BC is 2x plus 8. Let's find x, let's find AB is BC. Well, since these are congruent, that means they're equal to each other. So say 3x minus 2 is equal to 2x plus 8. And all we have to do is solve this, right? And same rule as before, we only want to get one variable. So let's get rid of the smaller variables, minus 2x from both sides. So we have x minus 2 is equal to 8. Now let's get rid of that plus 2 and isolate the variable. So these cancel out and we get x is equal to 10. Remember, that is not our final answer. They want us to find AB, BC, and AC also. Well, I'm gonna substitute in for BC because that looks like the easier one. So BC is equal to 2x plus 8, but now we know x is 10. So we're gonna substitute it in. We get 2 times 10 plus 8, which is 20 plus 8, or 28. So this is 28. Since they're congruent, this is also 28. That makes AC 28 plus 28. Also known as 56. And that's the lesson.